Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about Delta Lake. So Databricks has something called Delta Lake, and this is something that has been used by people very frequently. And we are going to talk about what is a Delta Lake, why we needed Delta Lake, some of its salient features, and also some benefits. So let's get started. So first of all, what is Delta Lake? We have all heard about data lakes and why data lakes came into picture, what do they do? But Delta Lake is, you can say, an advanced or enhanced version of a data lake. Delta Lake is nothing but an open source storage layer that sits on a cloud object store. Now, Delta Lake, since Databricks is available on all the prominent cloud vendors like AWS, Azure, or Google, so Delta Lake is a feature or a concept that Databricks provides. So this is available as a storage layer that sits on any cloud object store. It can be Azure Data Lake storage or it can be S3. Why there was a need of Delta Lake? So we have all used Data Lake at some point or the other, and that is nothing but a central repository where data can be brought in from multiple places. But with data lakes, the thing was that it was always a schema on read. There was no enforcement of schema when the data was written into the data lake. That was also an advantage because you could write any volumes of data, any type of data, whether it was structured, unstructured, or semi-structured. That was the USP or the advantage of a data lake. But at the same time, this advantage also has certain negative or certain disadvantages, like there was no enforcement of schema when the data was written into the data lake. There were no ACID properties that were provided. So atomicity, consistency, isolation, and durability. These are ACID transactions which were available to us or very important to us when we were in the RDBMS world. But in the distributed data lake setup, ACID transactions were not possible. So this was a limitation in certain use cases, and people who have been using RDBMS and are used to ACID transactions, they found it not good to have a system where there were no ACID transactions. So that's where Delta Lake came in. Databricks came up with the concept of Delta Lake, or a facility to have a storage where you could have ACID transactions. So that is where Delta Lake concept came in. It is an enhanced version of what we have been using since long as a data lake. Now, what are the different features that a Delta Lake provides? So one of the features definitely is what I spoke about, which is nothing but ACID transactions. Then schema enforcements, because now there was a provision to enforce schema on the data that we are putting in. Schema evolution, which means if my schema changes over time, which is most of the time the case, when we bring in data, our schema may be of certain type, but with time, with changing requirements, the schema also evolves. So Delta Lake, one of the salient features is it gives a schema evolution. Update, delete operations on the data in the Delta Lake is possible. Metadata handling was given out of the box. So these are some of the very unique or prominent features of a Delta Lake, and it really helped people who had certain use cases or scenarios where ACID transactions or schema enforcement, schema evolution was required. Now, when we talk about Delta Lake, we saw what is there in Delta Lake, which is different from the original data lakes. But there is one concept which is extremely important to understand, which is the Delta table. So when we talk about Delta Lakes, Delta Lake is a concept. But if we have to implement that concept in Databricks, what we do is we create tables called Delta tables. So while creating a table, you can specify that it is a Delta table. Now, what is the benefit of having a Delta table, or what is the data format in which a Delta table stores data? So in a Delta Lake, there is a transaction log that gets maintained. That log is called a Delta log. And that transaction log is very important because it stores every transaction that is getting performed on the delta table since it was created. And this is where we can have that entire lineage which tells us what happened from the day the delta table was created. This will also help us in terms of the ACID transactions or doing schema enforcements, because we have this entire history or transaction log for that delta table. So if you create a delta table and you actually go and look at the folder structure, you would see a folder which is called delta log, and then you would see your files which are data files. So if I copy data into a delta table, I would have a number of part files which are if I'm like putting in a Parquet file, I will have a number of files which are snappy, compressed and Parquet, and I will also have a folder which is nothing but a delta log folder. Now this delta log folder, if we open that folder, it will have CRC and JSON files for every transaction. So we are recording each and every transaction details, and for every transaction we will have a CRC and a JSON file inside the delta log. And this is important because this is giving us the flexibility of having ACID transactions. Now, one more important thing to remember is if we delete records from the delta table, the file from the storage is not deleted immediately. The file is maintained for some time, and that file is maintained because there is a facility that your delta table gives, which is time travel queries. You can actually go back in the time and see what data was stored because there is an entire transaction log, because the actual data is not getting deleted immediately. The only way that we can clean up this data files which were deleted or the stale data is by using a vacuum command. But otherwise this data is maintained and there is a flexibility, and one of the good features that delta table provides is time travel queries. So what we looked at is those CRC and JSON files inside the delta log, but what exactly is the information that is stored in those CRC and JSON files? So in that delta log folder, there is a JSON file. The JSON file ideally has the commit info, which means it has details about how many records have been written as a part of the transaction and the number of files that get created along with the cluster ID and notebook ID. So it is giving you the entire trail of the transactions that are happening. This is the commit info. It was giving the number of records. And this is based on transaction because we are talking about ACID transactions. So for every transaction, we have a JSON and a CRC. The JSON tells me how many records were written as the part of that particular transaction and how many files got created. Similarly, there is a CRC file which gives us details about the size of the entire delta table and the number of files in that delta table. So these two, CRC and JSON, are very important because they tell us the entire information about a particular transaction and it is maintaining the transactions. So let us talk a bit more about ACID property, and I'll give an example of a write request to explain how delta tables are helping us to enforce ACID properties. When we talk about a write operation, ideally there are three things that are happening in the background: read, write, validate and commit for any write operation. And these write operations are said to be optimistic concurrency. There is an optimistic concurrency control. So we'll try to understand what does this mean, and this will help us to understand how ACID properties are maintained by a delta table. So when we are doing a write, there are three things like I said: read, write, validate and commit. Read means whatever is the latest version of the table in which the file needs to be modified is read. So there is a table, a delta table which is existing. It has some existing data. So first of all, even before writing, a read operation is done, which means we are reading a version of whatever data today resides in the delta table. Then the actual data write happens where new data files are written, and all of these are getting maintained in the transaction log. The third and the final step is to validate and commit, which means we have read the latest version existing in the delta table. We are writing our new files, and in case, now the third step is in case there is a conflict, instead of corrupting the table, the write operation fails with a concurrent modification exceptions. If there is no concurrent request, if there are no conflicts, then we will simply read the latest version, write it and validate and commit. But essentially this validate step is ensuring that there are no conflicts there before making a commit. And the final step is committing, which means whatever data I was writing is now committed because we are talking about transactions. Hence, we are talking about a commit. Now, when we talk about this kind of optimistic concurrency control, what is delta table doing? The delta table, like I said, has a delta log, which is nothing but those JSON CRC files which are maintaining that entire log for the transaction. So whenever there are concurrent transactions, Delta Lake will handle it both mutually exclusively, which means there will be only one transaction that will be accepted, then the other will be rejected. Because it is a distributed system, we can have concurrent users, we can have concurrent requests. But if the request is a conflict, it will maintain that exclusivity, which means there will be only one transaction accepted, the second one will be rejected. And when will that be done? In the third step, when I am doing a validate. I will take only one, I will reject the other. And by doing this, it means that we are handling all of these scenarios optimistically and updates the table for one transaction, creating a new version of the table. So whichever transaction is accepted, that is committed to the table and a new version of the table is created. So whichever is the second transaction will have an older version, and that is why it will not be committed. Because every time before doing a write, we are reading the current version and then deciding whether there is a conflict. Do I accept the transaction or I reject? That is how the delta tables are using the delta log and the current versions to maintain optimistic concurrency control and avoiding any kind of conflicts. That's how transactions are maintained. Now, we spoke about how Delta Lake works, how tables are stored, how are we doing the asset transactions. Now, one more important thing is to understand how performance optimization is done for Delta tables. So, there are three features, I would say, which are for performance optimization. First is compaction, which is also known as bin packing. The speed of read queries can be optimized by compacting small files into larger ones. So Delta Lake or Delta tables automatically do a bin packing or compaction by which they are not reading small files, they are combining small files into larger ones, which will give definitely a performance boost. The second important thing that Delta Lake does is Z ordering, which means Delta Lake provides a technique to arrange related information in the same set of files. This will help in reducing the amount of data that needs to be read. So we don't have to do a lot of back and forth because Delta Lake by itself is arranging related information in the same set of files. Now there is a column named Z order by clause which is used to collate the data because we are the ones who are telling on which column or Z order, by that Z order clause we are telling on which column we should actually group the data. So this is something like we manually do partitions, we do partitions, we do bucketing. This is something like a Z order which Delta Lake itself does to group the data. And another feature that is there is vacuum. Now vacuum is a command that is used to delete the compacted file. So I spoke about it briefly in the previous slides that when we are actually Delta Lake doesn't delete the data immediately. It keeps it to support time travel queries. But if I want to purge that data, then I will use a vacuum command. The default value for deleting the file is 7 days. That means if the files that were compacted before 7 days will get deleted when we call the vacuum command. So these are three prominent features by which Delta Lakes give a performance boost. So yeah, this was in nutshell a brief overview of how Delta Lakes evolved. Why are they important? What do they do? I hope this helps. Thanks so much for watching.